Welcome to my favorite meme. Today we are going to do the integral of e to the power of negative x times s of x over x from 0 to infinity. So this xi is the inverse sine integral. This is a special function. Today we are going to integrate. But do we have any ideas how to integrate? So we have an x in the numerator denominator. It will be very annoying, So I want to produce the extra x to cancel each other out. So let I of a use our Feynman technique. I of a is equal to, where should we put the a though? If we put down an a here and then differentiate both sides, you get, just cancel the x and x. You just get e to the power of something times e to the power of negative ix times s of x. Can we integrate though? I'm not sure, but you can try put the a on here. You can do it by your own, but I'm going to put the a here, xi of ax this time. So e to the power of negative x times xi of ax over x. So we can differentiate both sides now, which respects to a now. So since e to the power of negative x over x is a constant, so you can put it in front. So remember, a should be greater or equal to 0 here. It will be convergence. A is greater or equal to 0. So if a is equal to 0, that will be convergence as well. Because if we plug a is equal to 0, s of 0, you pretty much just get 0. So integrate 0 from 0 to infinity. Because 0, it doesn't have any area, so you will get a 0. So that integral will converge. Converges if a is greater or equal to 0. So you will get, we are going to differentiate s of ax. First you will get sine of inside over inside. And then differentiate ax. Because we are in the a world, differentiate in the a world, x is just a constant, so you are going to multiply by x. This. So you can see this x and this x, they cancel each other out. So you will get, put 1 over a in front of the integral. So you get e to the power of negative x times sine of ax over x dx. Integral of this from 0 to infinity. So what is this? We have already done this integral on my previous video. You can check it out. So let me tell you, this is just equal to inverse tangent of a. So let me just put it here. Inverse tangent of a over a. Let me write like this. So you get I prime of a will be equal to inverse tangent of a over a. So we are going to integrate both sides, but can we integrate it though? Inverse tangent of a over a. Of course no, if this dimension functions. But if we use some special functions, you pretty much just get the integral of this is just the inverse tangent integral. It's called ti2 of a, like that. And then, because we integrate both sides, don't forget about the constant c. So you get like this. But we are going to figure out what the constant is. So I of a is equal to that. So you get this. And then we are going to put a is equal to 0 this time. The ti2 of 0, you get 0 plus c. And then this, I already tells you, s of 0, you get 0. So for this entire, you get 0. Entire thing. So you will get c will be equal to 0. So our I of A, this one I of A is just equal to the inverse tangent of inverse tangent is called TI2 of A. I don't know what it's called, but TI2 of A. So we are going to plug 1 because compared to each other, this A is just equal to 1. So ladies and gentlemen, this integral will be equal to this TI2 of 1. Yes. But we are not done yet. TI2 of 1 is actually gives you the Catalan's constant G. Yes. This integral is really, really cool, you know. G. So you can try the definitions of the inverse tangent integral, and that's it. G.